All right, good morning. So what we're going to do today is we are going to talk about function composition. And it is the 2nd of November. So this is kind of a new sort of thing that we're going to be talking about today, but it relates to something else. So first I'm going to start by defining what does composition mean? So we're going to define composition. And what a composition is, it's building a function where the output, so what comes out of it, that y value of 1, or the solution of 1, becomes the input, so our x value, or what we plug in, of another. So basically what this means in more simpler terms is you are plugging one function into the other. It's kind of like substitution, but a little bit different. So that's why we call it composition. So when the way you know if you're doing composition or not is you'll see certain notation. And just like with when we're adding, subtracting, things like that, we have two different things that mean the same for the composition notation as well. So what you first might see is f of g of x like this. And notice whenever I see a parenthesis, I say of, that kind of means like it belongs to it. Or you might see it as f of g of x. So this little thing here, that does not mean to multiply. It has to be a solid dot for it to mean to multiply. So this is not multiplication. I just want you to make sure you see what all of the different forms are of if you run into this notation. This one is the most common notation, but sometimes you will run into problems that look like this, and that means that open circle there means composition. So let's figure out, what does this mean? How does it work? So let's do an example. So say we had f of x equals 2x plus 1, and we have g of x equal 3x. So we're used to seeing like different functions and stuff like this, but this is where it gets tricky. Say I want you to find f of g of 7. So this looks super, super weird. We're not used to this. But what we are used to is, say we're just looking at g of 7. So whenever you use function composition, you always start with what's on the inside. And I have g of 7 on the inside. And I know how to do this from what we learned a couple weeks ago. This is just evaluating functions. So my g of x is 3x. So g of 7 would be 3 times 7, which gives us 21. Now what we do, we know what the inside is. I don't care about that anymore. I'm going to replace it with 21. So I'm kind of starting on the inside and then going to the outside. So I have this f, but instead of it being f of g of 7, it's f of 21. So now I know how to do this. This is just my regular evaluation. So my f of x equation is right here. So it'd be 2 times 21 plus 1. So that would give me 42 plus 1, which is 43. So that means my final answer, this f of g of 7, is 43. So function composition is plugging one function into the other function. So we're substituting that in. Let's try another one. So our second example. Let's say we're going to find f of g of 2. So we want to start inside. So our inside is we have this g of 2. So I go to my g right there. So g of 2 equals 3 times 2, which is 6. I now replace this. So g of 2 equals 6. So I can write 6 instead of that g of 2. Now I have f of 6 instead of f of g of 2, because 6 is the same thing. And I can find that by plugging in. So I go to my f, I have 2 times 6 plus 1. So 2 times 6 would give me 12 plus 1, which is 13. So my f of g of 2 is 13. We're going to do one that's a little bit more complicated to see if we got this. So for our next one, we're going to change up what we have. So for our example 3, let's now say that f of x equals 3x minus 1 and g of x equals 2x plus 3. So we're going to use these two ones now. And say we're going to find f of g of 1. So sometimes I will say, remember, these are just names. They can change. It can be h of g, g of f, whatever. This is just, I'm just writing it like this because that's what I'm doing. Whenever you see problems, it can look different. So I always, again, start on the inside. My inside is g of 1. So I plug it in. So I have 2 times 1 plus 3, which would be 2 plus 3, which is 5. Now I want to replace that 5. So now I'm finding f of 5. And we do what we've been doing. We want to plug it in. So I plug it into my f of x, which would be 3 times 5 minus 1, which is 15 minus 1, which is 14. So 14 is my final answer here. So I'm going to show one last example. And this one we're going to work on more tomorrow. But I just want you to kind of see it to start thinking about it. So I'm going to turn my page for this last example. I probably have enough space, but I'm just better safe than sorry. So my last example that I'm going to show is a little bit weird. So example 4. So I'm going to use that f of x equals 2x plus 1 and that g of x equals 3x from that previous couple problems we did for this. So we're used to seeing things with numbers. Note how when we had those with numbers, we had a number for our answer. Well, what if we find it asks us to find something like f of g of x? So this doesn't have a number. So that means your answer isn't going to be a number either. but you do the same thing. So you start with the inside. So I start with g of x, and I'm like, but what, miss, there's nothing to plug in. So then I don't plug anything in. I just rewrite it. I have 3 of x, and that's what I'm going to replace here. So this becomes 3 of x. And you do the same process. So now I have f, and instead of it being of a number, it's of 3x. So it's a little bit trickier. So now I want to plug in. So I have 2 times whatever my x is going to be plus 1. My x is 3x. Now all I do is simplify. So this is multiplication. So it'd be 6x plus 1. I have no more like terms. I'm done. So that last problem is a little tricky. I just wanted to show it to you to know that this is where we're heading. But for today, just note, there will be numbers. And if you have a number there instead of a variable, you should have a number for an answer. So we're going to work on our Desmos. Have a good break.